Alright, so then MySQL stored procedures. Stored procedures are actually a collection of SQL statements that you've put together. And the advantage of having stored procedures is that it allows you to put some sort of business transaction, just like I explained to you. If you have a couple of things that you want to work together, then you can use a stored procedure. So the example I have here is actually a terrible example from a different database. So I have the example in the next slide. So the advantages of using a stored procedure is that it reduces network traffic and allows you to increase the performance of your application. So if you have an application program that has to do a lot of input output operations to your database and calculations and manipulation of the data to put it in there and then to bring it out and so on, you're going to have a lot of network traffic where you're sending requests to the database and the request is being replied back to the application side. But if you do everything on the server side of your database, then all the calculations and everything will be completed there, and then it will just give you just like a one-way request send, and then getting the output where everything is calculated in at one go. So, and it allows you to isolate those codes and just write all the data manipulation codes within your stored procedure, and allows you to now do your the other functionalities of the application on the application side. So the example of the stored procedure that I have in for our own database is that we want to create a stored procedure that will allow you to return a book. How do you return a book? Remember, we have a borrowing table that keeps record of a book that is borrowed, and we had columns that were supposed to be populated when the book is returned. So it will now go into the borrowing table and update those appropriate columns. But first of all, it needs to determine whether that book is overdue or not, because if it's overdue, then there's a fine that you need to um, there's a fine that you need to pay on that book for returning it late. So the codes are a bit long, so I couldn't add them in this slide, but I created a file, return procedure.sql. You can open it with a text file with any text editor to look at the content, and then you can copy and paste it in your we're going to see it in the MySQL workbench and see how it works. So there are other examples of stored procedures on this tutorial website that you can go and find. So let's now go to the stored procedure on the workbench. So stored procedures are not unlike triggers where you create a trigger on a certain table. Stored procedures are not created on any individual table because you the edit button here. So under your stored procedure, so let's pretend to create a new one, and then it gives you a blank field where you can now add all your codes for your stored procedure. So you can change this name, give it the name you want. If you have in parameters or out parameters, you put those. I'll explain what those are in a bit, and then you write the code within the begin and end place. So but we are not creating, so you will create that. So you can actually copy and hold on. So you can copy and paste the content of the .sql file with it. So I'll just go through line by line and explain what it means. So of course you have the create procedure, the name of the procedure, and then we have some of those variables to work or do certain calculations or do within the SQL statement of that procedure. If it's an out parameter, then that means it's going to be the result that will be displayed back to the end user or sent to the application side. So of course the in parameter can also be collecting it from the application side, but MySQL Workbench allows us to have an interface that will just let you provide the in parameters directly, or you can write it in an SQL statement. So I'm creating a bunch of in parameters here. We're only using in parameters for this example. So you now say after the name of the procedure, you open a bracket and close a bracket. Within the bracket, you put the list of your parameters. So you put whether it's in or out. In this case, it's in. I'm naming it library user, lib user. It's an integer. I want to use this to collect the primary key for the ID for that user, you put a comma and then the next. So you have to make sure you declare the data type of that parameter. So then the next parameter is book parameter. This will allow us to collect the ISBN of that book. Then it's a variable character. So I'm very clever, okay? So I know that my user ID is an integer. I know that the ISBN is variable character. Borrowings I'm returning, because if you have a certain book borrowed by a user on a particular date, that's one borrowing. So I need this as well. And then I also have the condition of the book, because I'm imagining that the librarian that is collecting the book for the return will assess and see what condition the book is in. If it's in a good condition or not in a good condition, then they will have to record that in the system. So I'm also creating a end. So if you know that you need to use any variables, actually as you're writing your code, you can go back and forth. So if you know you need to use any variables, you have to declare them immediately after begin, otherwise they won't work. Okay, so I'm going to ignore these two lines for now where I declared these variables. I'll explain them later. So let's go to the first thing that we need to do to record the day the book is returned and its condition. So we've got this okay, let me just close some of these tabs. Too many tabs open. Cancel. Okay. Don't save. Okay, so I have who borrowed it, what was borrowed, and then it determined date it was borrowed, when I need it to be. So I need to now use my stored procedure to update these values, the date that it was returned, to determine whether it's overdue or not. If it's overdue, to calculate the fine amount, and also to record the condition that it was returned in. So let's go back here. So we have to record the day the book is returned. Hold on, I have two of these open. Okay, that's fine. So to record the day the book is returned and its condition. So I'll now use an SQL statement. Regular SQL statement, nothing too fancy. Update my borrowing table, set actual return date. Remember, actual underscore return date is actually a column in my borrowing table. Okay, this borrowing table, this column. Okay, so I'm going to now, I'm doing an update command. It's not an insert command because I already have the value of that borrowing. All I'm doing is updating it to change, to actually fill in the missing parts that needed to be updated after the book is returned. So I'm saying set update my borrowing table, set my actual return date to be equal to current timestamp. So I'm being not specific. I'm not going to give a specific date here, obviously, because the dates for the return will vary depending on the day that that book is being returned. So all it needs to do is check. If I'm returning it today, it will check today's date and put it. If I'm returning it tomorrow, it will check whatever day I'm trying to insert the value in there. It takes it as the day of the return. So current underscore timestamp, we've used this before. So then another column that needs to be updated is the return condition. We have somewhere called return condition, and I'm setting it to be equal to book condition. Remember, I created an in parameter called book condition. So whoever is returned the book, the librarian or the student, depending on what the interface is, who the interface is asking to put those values, is going to be asked to supply this book condition, return condition in our borrowing table. But it's not going to update. Remember, if you do an update without a where condition, it will update the whole table. But that's not what we want to do. We have a particular row within the borrowing table that we want to update. What's that row? We define it with the where condition, where the user ID is equal to library user. The same thing. Library user is supplied by the person returning the book or the librarian. Okay, so you need to put in, okay, this book, this person, this date. And
Yeah, so when these, it will now check it and make sure that only that row will be updated with whatever book condition you've supplied and whatever today's date is for the current timestamp. And done. So you've done one thing here. You've only updated what? Two columns, the return date and the return condition. But you still have not decided whether that book is overdue, and if it's overdue, then you're going to have to pay some fine. This is where our if statement comes in handy. So to determine if that book is overdue and also calculate a fine, then you're going to now use an if condition. But before you use the if condition, you need to now use a so I'm going to skip this line of explanation and come back to it also, like I skipped the top one. So I have an if condition. If this returned on is greater than expected, but what is my returned on? I have the syntax for an if then condition is, you say if you give a condition, then do certain actions, and you end if. Or if you have an alternative, you now say else, do a different kind of action, then you end your if statement. But for me to define this condition, I need variables. Variables apart from those that I have created as my in parameter. I need separate variables that will be checked from the table. So now I've already added values in the table that has, I already have my date that it was returned and the expected date of return, which, if you remember, our trigger calculated for us. So, but how do we now get those variables? So remember, I said earlier that if you need to use a variable anywhere, you need to declare it after your begin. So after the begin, I go back and I declare a variable. I called it returned on. Okay, I'm giving it a different name so it won't be confusing with what we have in the column names. So I have a returned on a particular date, and then I have expected, two variables, returned on and expected. These are the things I will compare. And then you come down here right before your if condition, you now select, you now assign values to those two variables that you've created. You can use a select statement to assign a value. There's a special kind of select statement, you say a select into. So I'm saying select actual return date, comma, expected return dates, these two columns from my what? Borrowing table. What am I selecting them into? So you say select these two columns into these two variables. So select actual return date into returned on, expected return date into expected from my borrowing table, but not all. Okay, I'm only doing it for one line, one row for that particular return. So I'll now say where user ID equal to this, just the same condition I did when I was doing the update. Okay, so where user ID equal to the library user, the one that was supplied, book ISBN equal to the book from our in parameter also, and date. So here, if you notice, I did something slightly different. The same thing here. Okay, instead of saying where date borrowed equal to borrowing date, I have a date data type for my borrowing date here in my in parameter, and I have a date time data type in the table for my date borrowed because I wanted to see the time component. But I only need to compare the date component. So you can use a function called date to pull out only the date part of your date time. And that's what I did here and here. Okay, so you have the date bracket open, date borrowed. So it will now take this column called date borrowed, which is a date time, and only extract the date part of it, then compare it to the borrowing date that I've supplied in my in parameter. And after doing the select statement to assign your values to your variables, now your variables are ready to be used. Then you use them in your if condition. You compare, you say if my returned on is greater than expected. If you know, dates can be you can do comparison operations and mathematical expressions on dates because they are numbers as well. So if I returned it on a day that is more than the day I was supposed to return it, that means automatically it's overdue, right? So you now say if return day is greater than expected, then update the borrowing table. Set the overdue column to be equal to yes, because if this condition is true, that means it's overdue, comma, then also set the fine amount to be equal to, then you calculate the fine amount. I don't remember the exact amount of the fine, but I'm assuming that it's 100 naira per day. So you now say 100 times returned on minus expected. You just like you can do comparison, I said you can do mathematical operation. So if I subtract one day from another day, I get the number of days in between the dates. So if I return it today and I was supposed to return it like day before yesterday, if I minus day before yesterday from today, I will get 2 as my output. So if I get 2, that means 2 days, and if it's 100 naira per day, it will do 100 times 2, and it will give me the amount I need to pay. So it will update the borrowing table, set overdue to be equal to yes, fine amount to be equal to 100 times the number of days it's overdue for. Where also this condition, because remember you're not doing the update on the entire table, only where these conditions. So always use this condition to make sure you're working with the same book, the same user, the same borrowing basically. Else, okay, so if this condition is not true, that means if it's not true, what's the opposite? It means that I have returned it either on the day I was expected to return it, which means this is equal to this, or even before I was expected to return, which means this is less than this. In that case, I don't have any fine that I need to pay, and my overdue will not be yes, sorry, it will be no. So else, update borrowing, set overdue equal to no. And you also have the where condition, where these conditions are true, and end of statement. Then you end your if statement and also end your stored procedure. So you apply this. I've already applied this, so I'm not going to do it twice. I have the procedure. So you click on apply, accept, and it's there. So once it's there, how do you now run it? You come to you refresh this, and it should appear on the stored procedure, your return procedure. You can see mine here. So you can execute the stored procedure. If you click on this, it will give you an interface, and it will ask you for all those in parameters that you had. So let's say let's cancel this for a minute so we can check the date. Let's go to the borrowing table. That last item we added, the 200 and 300. So user 200 borrowing book 300 on this day. Let's assume we're returning it on the same day. The person can read really fast and they've finished it, and you want to return it on that same day. So we should be able to do that. So just look at the date. We are only interested in the date part of the date borrowed. So that's 30th of 03 2020, and it's user 200 and book 300. So you go back to your hold on, so let's just execute this again. So the user 200 book 300, the date of the borrowing is the date, I think the format matters, I'm not sure. So 2020 03 30th, so 30th of March 2020. What's the condition we're returning this book in? Let's assume that we didn't tear it, so it's in good condition. So if you execute this, you can now see at the bottom here, it says one row affected, 2 warnings. Okay, so there's problem somewhere. I can't really see what the warnings are, but we've got the SQL statement that is used for the execution. Okay, so you can see, you can type it directly. If you don't want to use the graphical user interface, you can just say call the name of your procedure, open bracket, then supply all those in parameters in the order of which you declared them. So remember, we declared what? The user, the book, the date, and the condition. So you write them in this way, and you can run the SQL statement. So let's go to our borrowing table and see whether this has been applied. So you can see our user 200, book 300, it has been applied. So the expected return date was there before, so it has done all the comparison, the if condition, it automatically added our actual return date to be today's date, and it compared this and this. Since this is not since this is not greater than this, then it say that our overdue is no. So it's executing the else part of our if statement. How about if we look at, is there any book that is due? So I have a book here. You can manually add one and put the expected return date so that you can test the if part of the condition. So I have a book that is supposed to be due on the 20th of 03. 20th has passed, right? So let's assume I'm trying to return this book today. When was it borrowed? 19th of 03. Book 100 borrowed by user 100. So let's go back and execute our stored procedure again. So I'm just going to come here and edit it. Okay, so let's edit this one. So I actually have the same thing here. So I have my user 100 book ISBN 100, which was borrowed on the 19th of March 2020, and I'm returning it in good condition. But remember, today's date is 30th, and in my expected return date, it said I know that it's not the correct, it's supposed to be 3 weeks from the date it was borrowed, but I just added the date manually to test that my if part of the statement will actually work. So it's showing as if I'm supposed to return it 1 day after I borrowed it, but that shouldn't be a problem. Okay, so execute this, and you can see that one row affected. So go back to your borrowing table, run this query, select star from the borrowing, and check it. So you can now see it now said it's supposed to be returned on the 20th, but I returned it on the 30th. That means it's overdue. Overdue, yes. Remember, the other one, overdue, is no. Overdue is yes. I returned it in good condition, and since my overdue is yes, it calculated a fine amount of 1,000 naira, which is 100 times 10 days. If you subtract this date from this date from this date, you get 10 days. So if you multiply 10 by 100, you get 1,000. So I need to pay 1,000 to return this book. Okay, so basically that's the example that we have. So I'm going to give you an assignment. So what I need you to do for the assignment is actually just very simple. The first part of your project, part B, will be, I'll write it down on the Google Classroom, will be for you to do the trigger that we just did in this video and the stored procedure, and to test it on your own database and see that it works. So you can decide to do a video like I did. You can have voice or not have voice, I don't mind actually, and demonstrate how you executed it, how you checked by how you tested the trigger and the stored procedure by actually doing something and then checking in the tables whether the automatic actions have been applied, and you submit that. That will be your project part B. Then for the project part C, I will need you to create a trigger, but the trigger will use an if statement. I will explain what the trigger should do in the description of the assignment, but just the way we use this if statement in our stored procedure, you can actually use if statements in your trigger and give a condition. Okay, so thank you for listening. I hope it wasn't too long and it was easy to follow. One last thing, we're going to have a Q&A. Sorry, I think we have 2 slides left. Yes, so just very quickly. So embedded SQL. So this is just trying to compare the difference between embedding your SQL statement within your host language, which is the traditional way of using SQL statements within applications, or versus doing it in just the way we did it now, creating triggers and stored procedures and allowing it to run on the database side. So we call the language that you're writing the SQL statement within, or embedding it within, the host language, which are things like Java, Visual Basic, COBOL, and so on, C#. So now there are differences in terms of how the runtime works, how the processing does, and the data type. So the data type, there could be a data type mismatch between your traditional host language versus your SQL, which, as we all know, there are slight variations. Then in the processing, how it's also done may differ. And finally, the runtime. The runtime actually talks about when it's executed. So remember, if you're using the runtime, if you're writing your SQL on the server side, it is executed one SQL statement at a time. Okay, but if you're sorry, if you're writing it on the yes, on the database server side, it's executed one statement at a time, and all the execution happens on the server side. While if you embed your SQL within a host language, then your SQL statements are executed not at the time of compilation, but when you're running the application on the client. That's when the SQL statement is executed. So you compile the code, but it does not process the SQL statement. It processes the SQL statement as you're running the application or executing the application on your client machine, either your tablets or your laptops and so on. So these are some of the differences that you need to have in mind when you're deciding whether to use a stored procedure or trigger or to embed it within your host language. So how do you know if you have an SQL statement embedded within any host language? Always look for these keywords: exec SQL and end SQL. So this is a code block where your SQL statement will now be written within the exec and the end, and all host variables are preceded by a column. So when you're using variables from the host language, like as in parameters, for example, how do you differentiate it from variables that you're declaring on the server side? You'll see a semicolon at the beginning of the host variable, while for SQL statement, there's no semicolon. And also, there's something called a communication area that allows you to display, like if you have one other disadvantage, which is why I don't really like embedding my SQL. If I have an SQL error, how does my application return it? Sometimes you go to certain websites and then you now see the website turning all, like if you try to open some page and then there's an error. If it's an application error, it can actually tell you what the problem is. But if it's a database error, then it has no way of showing you what it is, unless whoever is writing that code actually knows how to use the communication area. So you have something called SQL code and SQL state. SQL state is what SQL code is, the actual SQL statement. SQL state is the one that tells you the state of your SQL execution, whether it's an error and what the error message is and so on, and then you can choose how to now display it to the end user. So for questions, obviously you can't ask me questions on the video, but what I plan to do is on Thursday, I'll announce the time that we're going to have a live session, preferably at the time of our scheduled class. So I'll expect you all to go online and connect to the the video conferencing application, and then we can have a session where you will ask me questions and I'll give you answers based on this lecture that we've just covered. So make sure that you try to do the assignments, make sure you read through the materials and actually watch this video very well over and over so you can get all the information and write down your questions, and then you can now have the Q&A session live on Thursday. All right, so thank you very much for listening, and I'll see and talk to you on Thursday.